Neural networks in control systems sound advanced only until you realize they are simply learning controllers that improve with experience. Welcome to the Learning Studio, where we don't just teach subjects, we break them down to their core intuition so you understand why modern control is evolving, not just how new techniques are labeled. Most students think neural networks for control systems are meant only for AI researchers, but in reality, they exist to solve a very practical problem: how to control systems accurately when mathematical models are incomplete, uncertain, or too complex. Classical controllers work well when system behavior is well understood, but real-world systems often change, age, or behave unpredictably, and that's where learning-based control becomes powerful. To see this intuitively, think about how a human learns to balance a bicycle. You don't know the equations of motion, yet through experience, your brain adjusts actions based on feedback. Neural networks work in a similar way. They observe inputs and outputs, learn patterns, and gradually improve control decisions without relying entirely on fixed equations. At a deeper level, neural networks can approximate complex, nonlinear system behavior and adapt controller parameters in real time. They can be used to model unknown dynamics, tune controllers automatically, or even replace traditional control laws when conditions change. This makes control systems more flexible, adaptive, and resilient. On a larger scale, neural network-based control is used in robotics, autonomous vehicles, power systems, industrial automation, and aerospace applications. These systems operate in environments where uncertainty and variation are unavoidable, and learning-based control allows them to maintain performance despite those challenges. In real engineering practice, neural networks for control systems are applied when designing adaptive controllers, improving tracking performance, handling nonlinearities, and reducing dependence on precise modeling. Engineers combine classical control principles with AI techniques to build intelligent systems that learn and improve over time. Now that the intuition behind neural networks for control systems is clear, the next step is to explore reinforcement learning and adaptive control, where systems not only learn from data, but learn directly from interaction. And that's exactly what we'll cover next here at the Learning Studio.